In this video, we are going to solve a problem to calculate the rise time, percentage overshoot, peak time and settling time. Actually, the given problem is a unit feedback control system has an open loop transfer function g of s equal to 10 divided by s into s plus 2. Find the rise time, percentage overshoot, peak time and settling time for step input 12 units. So here input is step input but 12 units. From this figure they have given g of s value. Actually they have given the g of s value and input 12 units. From the open loop g of s, to calculate the closed loop transfer function, the formula is C of s divided by R of s equal to g of s divided by 1 plus g of s into h of s. So we have to substitute g of s value, h of s value. Actually here unity feedback system. Therefore h of s equal to 1. G of s equal to 10 divided by s into s plus 2 divided by 1 plus 10 divided by s into s plus 2. So here we have to take LCM. It means, so in the for this term denominator is s into s plus 2. So we have to multiply here, then it will become common for this term and this term. So simply we can say we have to take LCM. So now we have to multiply here s into s plus 2 plus 10 divided by commonly s into s plus 2. So here s into s plus 2, here also s into s plus 2. We can cancel both. So we will have C of s divided by R of s equal to 10 divided by s into s plus 2. Then we have to multiply this s inside. So s square plus 2s plus 10. S square plus 2s plus 10. So we already cancelled. So finally we will have 10 divided by s square plus 2s plus 10. The second order, we already know the standard form of second order transfer function, closed loop transfer function, C of s divided by R of s equal to omega n square divided by s square plus 2 eta omega n s plus omega n square. So this is second order transfer function, second order closed loop transfer function. This is standard form. So we have to equate this and this. We see this is standard form. From the given problem, this is the second order transfer function. From this we can say omega n square equal to, we see omega n square 10, here also 10. Therefore omega n square equal to 10, omega n equal to root 10. Next 2 eta omega n, we see we have to compare this and this. So 2 eta omega n equal to 2. So eta omega n equal to 1. We know omega n, therefore eta equal to 1 divided by omega n. So omega n equal to 1 by root 10. Therefore eta equal to 0.316. So this is the eta value. Next, we know rise time TR equal to pi minus theta divided by omega d. So we know pi value in terms of radian 3.14 minus theta divided by damped frequency of oscillation omega d equal to omega n into square root of 1 minus eta square. Actually, so we know right angle triangle. If this is eta, this is square root of 1 minus eta square, this will be 1. So this is opposite side, adjacent side, hypotenuse. So now from this triangle, right angle triangle, this is theta. So now tan theta equal to opposite side divided by adjacent side, opposite side divided by adjacent side. So we know eta value. So we have to substitute here tan inverse of square root of 1 minus eta 0.316 square divided by 0.316. So now if we calculate and apply, we will get theta equal to 1.249 radian, because we see here we are going to use in terms of radian. Therefore here also we have to use in terms of radian. So 3.14 minus 1.249 divided by, suppose if we use pi 180 degree, we can use theta also in terms of degree. but here we used radian, therefore here also we have to use in terms of radian. So then omega n value we know root 10 into square root of 1 minus eta equal to 0.316 square. So rise time equal to, so we have to substitute this value into calculator. So we will get rise time equal to 0.63 second. The next, percentage peak overshoot. So simply we know all the things, we have to substitute. Eta value equal to 0.316 into pi value radian 3.14 divided by square root of 1 minus eta 0.316 the whole square. So first we have to simplify this, then if we take exponential we will get percentage peak overshoot 35.12 percentage. Then peak time, so we know pi in terms of radian 3.14 divided by omega d. So we know omega d is omega n into square root of 1 minus eta square. Simply we have to substitute omega n equal to root 10 into 1 minus eta 0.316 the whole square. So we will get peak time equal to 1.047 second. Then next, fourth required thing is settling time. So for 5% error, settling time equal to 3t. For 2% error, settling time equal to 4t. So we have to calculate t. T is nothing but time constant 1 by eta omega n. So 1 divided by eta equal to 0.316, omega n equal to root 10. So if we simplify this, we will get t equal to 1. Therefore here for 5% error 3, for 2% error 4 into 1 4. So next, from the given problem we have to use step input is 12, but for rise time, percentage peak overshoot, peak time, settling time, we no need to use the given step input. Just simply we have to form the closed loop transfer function, then we have to compare with the standard closed loop transfer function. You will get all four required things. But for peak overshoot we have calculated for percentage. Suppose peak overshoot we can calculate for 12 units, step input 12 units. So remaining things are same. For example, rise time already we calculated 0.63 second. Percentage peak overshoot equal to 35.12 percentage. Peak time equal to 1.047 second. Settling time for 5% 3, for 2% 4. But for peak overshoot it will affect only peak overshoot. Therefore for 12 units we have to multiply peak overshoot. Already percentage peak overshoot equal to 35.12 percentage. For 12 units simply we have to multiply with 10. For 12 unit we have to multiply 35.12 into 12. So we will get the peak overshoot for 12 unit. So its value equal to 4.214. So that's all about the required things of the given problem. So these 5 are the solutions. So actually from the given problem, this 12 only will affect the peak overshoot. It will not affect the remaining time.